So in terms of the scope for our project, there are very many parameters that must be considered in great detail. And luckily for us, for LCA, we abide by ISO standards that outline these very clearly. I'd like to now go over some of the more key ones, the more common ones used within our project. And first of all, I'd like to bring up the system boundaries. And in our case, we use the idea of cradle to grave. And what this is, if you're not familiar, is looking at the product from the manufacturing of the building materials all the way up to the end of the demolition. On top of that, for academic buildings, because they have been replacing previous structures on campus, we also include the previous existing buildings. And also for our residential buildings, because as I mentioned, glazing is a hot issue, we would like to look more deeply into the energy use and more of the maintenance and operation. I'd like to also further add that for our project, we looked more into the building structure and envelope itself. We did not look into more of the finishing. I'd like to also add that all of this information that we have is intended for everyone. And what I mean by this is that LCA, it needs to be made aware to everyone because it does affect everyone. What we have here is a life cycle, and there are many, many processes that are involved. And what we need from these processes, what we need from these constructors and these manufacturers, we need them to contribute knowledge so that the LCA database can grow. On top of that, of course, our primary intended audience is for building developers, as they have the most direct impact on what buildings go all around the city. But of course, we also expect this to be of use to people in government, policymakers, and even other universities that may want to do further studies on the case. And that being said, all of this information will be provided on the UBCC's database, which is something that will be publicly made to everyone. Anyways, I would like now to pass it on to my colleague Manville, who will be discussing more of the details of exactly what it was we did next.
Just click there. Right there, okay. All right, so I'm going to talk about the methodology that we used to develop our models. The first phase, after we define our goal and scope, is to perform our inventory analysis. The purpose of this phase is to quantitatively model the characteristics of our buildings. And then after that, we perform our impact assessment. So I'm just going to give you a brief overview of all the steps involved in the model development, and then I'll go into more detail. So first, we performed our quantity takeoffs using a program called on-screen takeoff. We used those quantities and we put them into another software program called Athena Impact Estimator. This generated a bill of materials for us, listing all the raw materials that are going into these buildings and the building products. This bill of materials then connects us to the Athena Lifecycle Inventory database, which has all the resource consumption and emissions information for these construction products. We assess the impacts of these emissions and consumed resources using the Tracy Impact Assessment method, which provides us with our impact assessment profiles. So first, quantity takeoffs. So as I said, we used a program called on-screen takeoff. And after setting the drawing scales, this program allowed us to determine lengths and areas just by tracing the structural elements on the digital drawings. And the drawings are provided to us by the developers. Organization was important during this whole process. What we did was we broke down the buildings into 5 building assembly groups: the columns and beams, floors, roofs, foundations, and walls. It was also important for us to name each structural element using a standard nomenclature, giving each one a unique identifier. Documentation was important to maintaining transparency in the study. We produced 2 documents in Excel to help us with this. The first document is the inputs document. Here for every building element, we listed our known measured values, our unknowns, and the input values. The second document is the assumptions document, where we listed all of our assumptions, the limitations of our data, any calculations that we had. And so from there, we put our inputs into the impact estimator developed by Athena, Athena's Lifecycle Inventory database, which has contains all the information about the resource consumption, as well as the emissions from these construction products. Once we have this information, we assessed how they impacted the environment by using the Tracy Impact Assessment Method, which is developed by the United States Environmental Protection Agency. Our results took the form of impacts across 8 impact categories, and we'll get more into that in a few minutes. So that completes our model development. That's how we did our inventory analysis and how we assessed our impacts. So the next step in better understanding our results is the supply chain exercise. This involves calling product manufacturers and finding out if they have life cycle inventory information on their products and if they know where their raw materials come from. Because of the limitations of our studies, we used average North American data, but we thought it would be interesting to just try out this exercise to see where the materials come from. In the future of LCA, we'd like to see this kind of map produced for all building materials, just so that people can see how their decisions are impacting the environment. So now we are going to talk about the results of our studies. Hilda?